Okay, then let's keep working on it. Okay, so then before that, let me save this file with a different name. Okay, save as because this is not a OLS. This is just a linear regression, or I would say Bayesian linear regression. I would say just linear. Okay, regression, just linear. Yeah. Right. So then, what we have here, this MHM has the posterior samples for the parameters, right? So then what we want to know is their mean and standard deviations or credibility intervals, right? So then, just before then, okay, just to make sure. Okay, let me run this again. Okay. Yeah, it runs very well. Okay, so then mean is, I would say, posterior mean equals mean C, okay, MHM, right? This is posterior mean. In Korean, 사후 평균, right? And then I wanna let the posterior standard deviations reported post ST. This is STDC MHM. Actually, this STDC is not a MATLAB built-in function, so we have to make this function. This gives the standard deviations by columns. Okay, so then yes, let's make it. As always, open a new script, and it begins with function, and it ends with end. Then output is standard deviation, and the function name is stdc, and input is x, right? So then x is what? X is, I would say, T by K matrix, and then output ST, standard deviations. This is K by 1. This is standard deviations of the deviations of x by columns. Okay, right? So then there must be a method function that gives standard deviation, and then I can't remember what it is. Then just Google it. Okay, as always, just Google it. Standard deviations MATLAB. Right, so then how to calculate the mean, standard deviations here. Okay, so where is it? Looks like STD, right? Or nothing as standard deviation of matrix elements. Oh, that's in Korean, I guess. What about this? Yeah, STD. Okay. Oh, it's Korean though. How can I change the language? Where is the language? Oh, where is the language? No, I can't find the language. So right here, STD. Okay. Think, yeah, A is matrix, and it gives 1 by 3 vector. right? So then gives what it says it gives standard deviations by column. Yes, by column. Yeah, and then the output is a row vector, and what we need is the column vector, because column vector is a default in mathematics. So then SD equals STD X and transpose. That's it. That's it. Okay. And then I'll say standard deviations. Okay. And let me save. Save where? Not here. I wanna save to my library. Here, my library, because it can be used anytime. Okay. Save it. Okay. It's done. Okay. So then here stdc mhm. Okay. And we say this is standard error. Okay. Right. So then what else? Yeah, I wanna see the 90%, or say 95% credibility intervals. Right. Okay. Then credibility, or just cred intervals equals, it must be quantile of MHM, right? And then the okay, then it must be P is the probabilities. So then just to make sure, let me check this help. Okay. MATLAB is really user friendly. Okay, then P must be what? P must be column or row vector. Can't what? P is what? Let's see example. Example, where is it? X, and there's only P is scalar in this case. Okay, P is here. P is what? P is a row vector, right? P is a row vector. Okay, I can see that. Then, and also output is a row vector. Alright, so then I have to put, I want to compute 95% quantile. That it means I need to compute a quantile of 2.5%. 2.5 means 0.025 and 0.975. Right, and transpose. Otherwise, it must be a column vector. Okay, so then this is what? 95% credibility intervals, or in Korean, 신용 구간. Right. Okay. Let me report this posterior mean, standard error, and credibility intervals. Okay. So then DISP. Here is posterior mean and standard errors. And 95% credibility intervals. Okay, DISP. Oops, DISP. Okay, let me put a line here. Just for a better looking. Okay, and then DISP. bracket posterior mean. This is 4 by 1, right? In this case, this 4 by 1 because we have 3 exogenous variables and 1 variance. And this is also 4 by 1. What about this? What about this? What about this? This is what? This is 4 by 2, right? This is 4 by 2. Credibility intervals. Right. Okay. So then let me put another line here and here. Okay. Here's so then results. Okay. So then let me run this. And let's see the results here. The posterior mean is here 0.9, 0.9, 30.0, 1.6, right? Yeah. And this is standard errors and 95% intervals. Okay, and let me move this to the right a little bit more, yeah. This must be looking better. Yeah, much better, right? Okay, so then what about the true values? True values what? 1, 2, 3, and 4, right? So 1, 2, 3, and 2. Yeah, quite close, right? Quite close, right? And what if we have more data? Okay, currently we have 100. Okay, let me change it to 500. Okay, let me run it. Right, 1, 2, 3, and 2. Yes, we have more accurate. We have more accurate estimates, right? Because we have more data, right? This is not surprising error, right? Okay, so then let me go back to the case of 100 observation. Okay, and then okay, let's say I have 200. Yeah, 100. Yeah, yeah. Still, we have quite good estimates, right? So then, what you have the data which is not that informative. Yes, still we have 200 observations, but the larger observations, the more observations do not necessarily imply the more informative, the more information, right? So still we have 200 observations, but if we don't have much variations in independent variables, okay, so then this is not 5, say 0.05 and 0.05, right? So we don't have much variations in the independent variables, so that we cannot see the relation between independent variables and dependent variables very correctly, right? So then let me run this again. Let's see what happens, right? See, this is very close to true value, 1, but true value for the second independent variable is what? 2, but this is negative, right? This is close, right? I think these estimates are given just with luck. Okay, let me change the RNG. Let me say whatever. Yeah. Yeah, right. So this is close, but it's still negative, and this is quite far from the true value, right? Right. So, right. And then let me go back to the case. Here, 5 and 5. Right. Okay. And what else we can do some experiments. Okay. Then okay. right? Just make sure that your code runs without errors, okay? And then we are going to do some more.